A stunt cyclist is preparing a new trick. Okay.
Mhm.
The track on which he will perform the trick is shown schematically below. Most of the track is sloped at an angle theta. Okay. The
Yeah.
one part in between is flat. Rest is theta. Okay.
Mhm.
The cyclist start riding at A. In the riding down the slope from A to B, he transfers an amount of energy E from his muscles to provide kinetic energy to the rider bicycle system. Fine. And descends through a vertical distance h. Now, this is a very important line. When he's going from A to B, it's not like he's
Yeah.
simply sliding down. He's paddling also.
Yeah.
So through paddling, what he's doing, he's supplying some of its energy to the cycle system and the biker system, right? So they are
Yeah.
gaining kinetic energy out of the internal muscular energy.
Yeah.
Apart from that, Khushi,
Mhm.
the potential energy is also getting converted, right?
Yeah.
So there are two things that are contributing to the kinetic energy when it is moving on the flatter part.
Yeah.
Is it making sense?
Yeah. I got that. Yeah.
Okay, okay. I'm just explaining the question right now. And the cyclist leaves the track at B, traveling horizontally initially. Okay. He lands on the track at C at a distance L of the slope.
Mhm.
Okay. So then he goes on a projectile fall. He simply jumps from there and he directly lands at C. So during that time, the potential energy from B to C gets converted to the kinetic energy at C. Okay,
Yeah.
fine. Assume that the rider system has been modeled as a point mass of m. Okay, fine. Let's say the cycle and the man both are mass m.
Yeah.
Frictional, that the frictional forces and energy resistance can be neglected. Now, fine. Let's start. A का answer क्या है? What is the answer for the A? What do you think?
I put B.
You
I'm
put
not
B.
sure.
You put
Uh,
B.
that's
Okay.
disappointing.
ना 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 ऐसे मत सोचो बे. देखते हैं. देख मैं तेरे को एक चीज बताता हूँ. Let me tell you one thing. There is dimensional stuff also playing a role. For example, what they are asking you, they are asking you velocity. Okay, so
Mhm.
Khushi, you could very well check that whatever answer you are giving,
Mhm.
is it dimensionally correct? Like for example, you have got E by m plus gh. They both are having the and root of that. They are
Yeah.
having a dimension of velocity. So dimensionally, this is also correct. This is also correct. Which all are dimensionally correct. So there is no
Yeah.
point. We have to just get the answer. Okay. So what you did, let me
Well,
explain the process. Give me the process.
I immediately eliminated everything with cos theta because I thought we had to be working with sine theta for working along the slope. But I still like did the work properly. So what I did was I did for the weight along the slope, I did mgh sine theta, which am I
Just a
right
minute.
about that?
Give me a second. So basically, I will do it here and I will send this copy to you so that you can have a hints everywhere. Okay. So what I'm
Okay.
saying is we are talking about what VA, the component of velocity of the system along the slope immediately after the cycle has left the track at B. Acha.
What I've
So
done.
so first of
It was
all,
a stupid mistake too that I made. I
first
just
of all,
realized.
yeah. You get the V thing first of all. How to get
Yeah.
the V thing? Half mv square is equals to mgh plus E.
Yeah.
And now you have to take the component of V as V cos theta. So this is V cos theta beta, right?
Yeah.
So first find V, okay. Then take the component along the incline. What was the mistake you made?
I did the component along the line for mgh as sine. It should have been cos.
After doing so much, huh?
It
After
was so,
arriving to such a stuff, then you made this small mistake.
it was so disappointing. Like I got everything else. Why did
Yeah,
I do?
even I am not. I am disappointed by this now.
I'm very disappointed by this.
So you were like properly sitting with the mood for doing the homework, or you were in mid of something, and what was
I
that?
mean, this has been chaos. I had, I think, like literally half an hour to do this on
Uh,
Thursday night.
okay,
So yeah, I just did not have much time to do this, which is why I think I made a lot of mistakes.
no
But
problem.
yeah,
So the
this
answer for
this
the
week
A1,
too, everything's come together to this week. All my work.
okay, no issues. That is
Yeah.
fine. Don't take it too hard. Okay. So
Okay.
just try to figure out that. See, Khushi, the one thing is we have to improve ourselves even while we are working in pressure or stress. Okay.
Yeah.
That is a attribute that we will be needing, that is required in the coming times. Okay.
Mhm.
So let's not excuse for that. Let's mark it for the future.
Okay.
Fine.
Mhm.
So the answer is E. Fine. Chalo.
Yeah. Mhm.
Now you wish to revisit on the B part.
For no, I understand why I did it too.
Okay, what's the answer for B part then?
Uh, I mean, this is gonna be wrong because I used the earlier one, but I put C
Yeah, so
because
that's why I'm asking you, no? The
yeah.
cyclist leaves at t equal to 0 with initial speed v by considering motion parallel and perpendicular to the slope. Find an expression for the time taken to land at C. So if you want to land at C, the normal component will decide the time, Vn,
Okay.
because Vn is receding, becoming 0, and then while it lands, again Vn is developing.
Oh,
So
okay. I
V,
didn't actually know that, so I didn't do that.
okay, so is it like on an inclined plane, you have not worked out the time period of a projectile?
No.
Have you learned the projectile motion?
Yeah, we've done projectile motion, not on an incline.
Now let me tell you this hint, okay, so that you can remember this. For
Okay.
example, this is a projectile motion. You are launching something with you at an angle theta.
Yeah.
So if somebody asks you what is the time of flight, you tell 2u sine theta by g.
Okay. Yeah. Yeah.
So what is u sine theta? U sine theta is the vertical component,
Yeah.
and as it goes up, it will go on decreasing to 0. It will become 0, and again as it comes down, it will again become u sine theta. So the
Yeah.
time of going up and coming down. Okay, and who is controlling this? G is controlling this. Making sense?
Yeah.
Now, Khushi, over here, you see, over here, if you carefully see, this Vn, which is V sine theta, okay, this is
Mhm.
being controlled by the G component, like G ka ye wala component. What is this component? This is G cos theta.
Okay.
Making sense? In the similar way, U sine theta was getting controlled by G because both were
Yeah.
parallel, right? But
Yeah.
right now, the G thing is acting like this, but you have velocity like this. So G ka
Mhm.
component will be like this, okay?
Oh, I get it. Yeah. That's why I was so confused. I didn't know what was
Isn't it
happening.
a very good synchronization of what we learned over there to this part?
Yeah. This is a good question.
Huh?
This is a good question.
So the answer will be 2v sine theta upon g cos theta.
So 2V by G tan theta.
2v by g tan theta. Yeah. So the answer
V.
will be B.
Oh,
Making sense?
yeah, yeah. Oh, this makes so. I think we just haven't done enough projectile motion for this in school.
You haven't done enough.
Yeah, enough practice on like slopes because I think we've only ever had one question with projectile on a slope.
So what you do, that is why I'm here. Okay. What you
Mhm.
do, you sum up every little thing, and
Mhm.
every day we have a class, like every week, we will do one subtopic in a little more detail. Okay.
Okay.
Whatever I do, I mean, I complete it from the school point of view, and I add a little bit to it for the entrance. Okay.
Yeah.
So uh, um, do a bit of micro planning, Khushi, and like
Okay.
in everything that you have gone so far, just try
Mhm.
to work out that, sir, I need to revisit a higher level of this concept, or I need some more practice. Then if the
Yeah.
things will come from your side, it will be very precise and it will be very efficient.
Okay.
So now I think this thing is in synchronization.
Yeah.
So I'm marking the answer as B. Okay. Now come to the C part. How far along the slope? Now you see, Now it's a very fantastic thing. Now something is moving like this, Khushi. You have got ux, you have
Okay.
got ax, and you want sx. Then sx is uxt plus half axt square.
Yeah.
Are you aware of this idea?
Yes. Yes.
Now along the slope, Khushi, what is the ax thing? The ax thing is g sine theta.
Mm-hmm.
See, ax is g sine theta, no?
Isn't it G cos theta?
G cos
Oh no.
theta.
No.
So we have already taken normal to the slope, no?
Okay. Yeah.
So you know how to break into components, or should I make it for you?
No. No. I do. I do. I just forgot.
It's okay, and never be shy of these small things. You can be very frank with me, like asking things and asking even the silliest of the possible questions.
It's
Not
okay.
to worry. So this is g cos theta, okay?
Mm-hmm.
Then the acceleration along the slope is what? G sine theta. Fine. Okay. And the initial velocity is VA. Now VA is V cos theta. Fine.
Yeah.
This is what? V cos theta, right? You know
Yeah.
the AX value G sine theta. So you can very well work out the displacement because you know the time also. Now this is the time it has taken to travel. Like it was moving in air, but I am considered about how much it has moved along the horizontal. Okay.
Okay.
Is it making sense?
Yeah. Yeah.
So this is given by Sx is equals to uxt plus half axt square. अब ux का value u cos theta है, ax का value g sin theta, and that this is the time value that you can put in. You can get a very small cute answer, right, of this small
Yeah.
equation. Uxt plus half axt square. Is it making sense?
Yeah. Yeah. I get it. I get it.
So what I am doing here, this is a, what is this approach called? Whenever you are solving a 2D motion, what is a 2D motion? The motion which is in a curvical format, which is not a straight line. But I don't know how to solve a curve. So what I do, I break it into components. I solve the x component separately. I solve the y component separately. Whenever I solve anything on incline,
Yeah.
I break it in two parts along the incline and perpendicular to the incline.
Mm-hmm.
This time what is being asked is the range along the incline. So I am using
Yeah.
all the variables which are lying along the incline right now to answer that.
Okay.
And that's why the equation which was told to you as s is equals to ut plus half at square, I have modified it.
Yeah.
Sx is equals to ux. That means I'm talking about the x components along the incline.
Got it. Yeah.
Understood?
Yeah.
Was it a over explanation or is it fine?
I overthought this, to be honest.
You?
I didn't even realize we could do simple projectile motion. I was trying to do some weird algebra and simultaneous equations.
But it was very well apparent.
Oh, I
No?
got the right answer. Oh no, C. No, I got the wrong answer. That's what I did.
You became so happy that whatever I did, I got the answer.
I know, right?
That is a eureka moment always.
I know, but it was wrong.
So will you please get the answer right now? You have
Yeah.
everything with you.
Yes.
Hmm.
This.
Ux is v cos theta, ax is g sin theta. Get the answer.
Is it not just C?
It is option C.
Yeah. It has to be.
It has to be.
Well, it's really simple once we realize what it was.
Mhm. No worries. Chalo. Just have a look at the D1. Now we have done everything once, like review, and I will like you to just revisit this question and give me the right answer now. You have the PDF with you on the computer. You can see the question over there or the
Yeah.
diagram. Yeah.
No, I can see I can see the diagram.
Okay. You have taken the printout or what for the homework?
Yeah, I have it down in my book. I drew it. I don't know if you can see that.
You have
pretty
written
well.
even the questions. Even the questions you have written.
Yeah. I like doing that so I can see what's going on.
No, I mean the whole language and all, everything.
No, not the whole thing. I have the diagram and I annotated it.
That's all. Okay. You should save time on that, right?
Yes.
Go ahead.
So I have to find, so I'm using a half T. Distance meaning. I have to- The last question was on,
Okay. Last question was?
right?
Your voice got stuck, Khushi. Your video seems to freeze up.
Hello?
Your video is freezed up. I can hear you. Hello. Hello. Shall I give you a call on WhatsApp? Like we can connect through voice over there. Hello.
Hi, can you hear me?
Yeah, I can hear you. I think you dropped out of connection, right?
I think I did. Wait, I'll try to join forward.
We can put the voice moving on here itself, right? So that there are two channels. One is Zoom, one is WhatsApp. Let the voice flow through WhatsApp. Okay. You disconnect your audio on Zoom. Okay.
Okay.
So that if even the connection breaks, we are in contact. Okay.
Yeah.
Yeah.
Okay, there we go.
Fine.
Am I in?
Now you're back on Zoom, and you can
I have to switch off my camera because I think that's what's stopping this.
Okay, no issues. No issues.
This is so annoying. I fixed it last weekend.
Huh?
I fixed my camera and then it broke again apparently.
It's okay. It's okay. Focus on part D now.
Mhm. So I know the time it takes.
Mm, to give the
to the
cyclist
top of the-
at what distance from B should the obstacle be placed? Okay. Clearing the obstacle, it should be placed at cyclist perpendicular distance from the track is greatest.
Is it D?
Let me see. So cyclist perpendicular distance from the track is when he's at the highest point, right?
Yeah.
So when he's jumping like this VM thing has reduced to 0 actually. That is the highest distance, right?
Uh-huh.
This is the highest distance, right?
Yeah.
So he's asking you about the maximum height. So you are telling me the answer as D.
Either B. I'm not sure actually.
You are quite correct on B actually, because this is V sine theta, right? So you know the yeah, huh?
You sounded like you were questioning me so much. I was scared.
The maximum height formula is U square sine square theta upon 2G, right? So so U square sine square theta ki jagah to V sine theta came up, and here you have G cos theta which is trying to stop. So it is very much synchronized with that. Okay. The way we manage time, no, right? Like from the yeah.
So it says what distance from B. So surely that's a triangle.
No. What distance from B? Okay. Yeah. So what you do, you get the maximum height first, and then you know this range half. This is this distance, you know, right? This is not R by 2. Mind it. This is not R by 2, because this is something you have to arrange from this by putting the time to reach the maximum height. Okay, because this time there is acceleration here. So this is not symmetric like it used to be on ground to ground projectile. Okay.
Yeah.
So be very careful with this.
Okay.
And you get this, and then you apply Pythagorean theorem to get this. So I don't think the answer will be B. The answer will be B for height only. Yeah.
I think it's D.
That is the most complicated answer.
That's why I chose it.
Yeah. Now I can. Yeah, that's right. A very different perspective to problem solving, right?
Yep, it works. Like 1/4 of the time, it's pretty much a work.
Great. Khushi's method, right?
Yes, guesswork.
What a guesswork, yeah. Chalo, it's fine. But I'm convinced that you also know the concept, right?
Yeah, I know. It's just I did not have time when I was doing this actual thing.
So what you could do, you can like take out like 15 minute slot. I will give you lesser homework from next time now. Okay, I think.
Next time, fine. It was just this week I had a crazy amount of work.
No worries.
So I just
Tell me,
yeah.
chalo. Let's comprehensively discuss these questions over here. Not to worry. Okay. Yeah.
Okay.
So if this is not done, I will ask you to do it. Okay. And right now we have switched out your voice from the Zoom, so you can switch on your camera. No, voice is connected from here. If it will get freeze, then doesn't matter. है ना?
Do you see me?
Not as of now.
This my camera just stopped.
Oh, the camera itself is like.
This is the problem, see.
चलो कोई नहीं, तुम problem करो 18th वाला problem and give me the answer.
18, I was fairly confident with 18, kind of.
Even I am very confident about you. So shall we check the answer? Shall we check the answer?
Yes. Okay, we can.
Tell me.
I got D.
You got D.
Yes. What's the answer?
Just a minute. Give me a second. Fingers crossed, right? It's B. It's B.
B.
B, yeah. B for Bombay.
Seriously? Come on. My math makes sense.
Huh? So why is it giving the answer? What is the kinetic of the ball as it first passes position P? A small steel ball is released from the top. After being released, the ball moves around to the lowest position and then rises to a height on the other Q. Oh, that means there is friction over here or what? Oh, yeah. Okay. What is the kinetic of the ball as it passes? So, Khushi, this one has become a really tricky question now. See, whatever kinetic energy the ball has gained till point P is not sufficient to bring the ball here back. It is only sufficient to move the half the distance. Yeah. Is it fine? Yeah. So basically, he's asking you what is the kinetic of the ball as it first passes through point P. So you know that during this journey, half the work is getting consumed. Making sense? Yeah. Let me tell you this way. Let's say the work done by friction here is W minus W. So what is the work done by friction over here? Minus W by 2. You agree to me? Yeah. Going from A to Q, the total work done by friction is minus 3W by 2. And the total work done by gravity is something you know. Okay. And you know that Q, the ball comes at rest. From there, you will get the value of W, which is the work done by friction. Okay. Now revisit the question again and apply that from A to P. Then you will come to know the velocity. Let me start like this. You have heard of work energy theorem, Khushi? What is work energy theorem? Work done by all the forces equal to delta K. Fine? Yeah. So I am starting here. I'll be sending this PDF to you. Okay. So let us apply work energy theorem on A to Q. Okay. Agreed? Okay. Now A to Q, how much downward displacement I have experienced? I have experienced a downward displacement of R by root 2. Making sense? Yeah. It doesn't matter whether the ball has gone like this. I am mainly concerned with the displacement in the gravity direction. So work done by gravity plus work done by friction equal to delta K. And this delta K is 0. You know that?
Yeah.
Delta K is 0. It is velocity at Q minus velocity at A. And I know that at Q it is at rest, at A it was at rest. So work done by gravity is how much? mg into r by root 2. This is work done by gravity. Now work done by friction is I have put it in the form of W in this part and minus W by 2 in this part. Okay, so it's overall minus 3 by 2 W is equal to 0.
Yeah.
That makes a lot of sense now.
Yeah.
Now you will do it by yourself. You will apply work energy theorem from A to P. I think
I can't see the diagram right now.
you can't see the diagram.
Yeah, wait.
Because
my laptop.
you have lost the connection, Zoom connection.
I lost it. Yeah.
That is okay. That is AP is the lower point. A is the top point. Okay.
Okay.
So A to P, work energy theorem we are applying. What is the work done by gravity? Tell me. How much is the work done by gravity? A to P.
MGR.
Perfect. Very good. What is the work done by friction?
Minus W.
Is equal to delta K. So let us assume that the speed at P is V. So it becomes half mv square minus the speed at A is 0, right?
Yeah.
Done?
Yeah. Yeah.
Okay, perfect. अब इसमें क्या करना है? What is the kinetic energy of the ball as it passes through point P? So we are concerned with this value, and you know W ka value in terms of mg and all. Get the value of W in terms of mg and all from the first equation and put it in the second equation. Okay.
Yeah. Yeah, I would get these. Yeah.
It's a good question, actually. It was not the easy one. It's a very good question,
Yeah.
isn't it?
I was so confident. I was so wrong.
Maybe you didn't make the right perspective. That's why.
Yeah, I didn't. I didn't even think of doing it that way.
Yeah, I know. So now is it clear to you?
Yeah.
So you see, Khushi, that whatever we have done in school is a good enough base, but we really need to build upon that to feel comfortable with the problems that are coming in, right?
Yeah.
You know? So it's good that we are touching upon mechanics first, right?
Yeah.
And almost Anga 2 is something I have almost covered, not fully covered, almost covered Anga 2 for mechanics.
Okay.
Okay, now this one.
Oh, I had so much working out for this, and I ended up with an answer that was half of one of the other answers. So I doubled it, and I called it a day.
You doubled it and you called it as
I called it a day.
D.
No, B.
Okay. So you got the answer as 3,500 newtons.
Yes, I did.
Send me the attempt on the WhatsApp on the group.
Yeah.
Just want to see. Yeah. Just want to see your attempt. Yeah.
No, okay.
Not to worry. Not to worry.
Don't judge my handwriting.
Arre, that is okay. Arre, we both have weird writings, right?
I can guarantee you.
No, chalega, chalega. I'm very resilient person, right? So I'm a very resilient person, especially being in India. Huh?
It's the one that says 3.
Okay, no worries. Let me check. So you did 0.6 into 5. Okay.
Yeah.
So that is area into V, which gives you volume flow rate. Okay.
Yeah.
Then you multiply it by rho. That gives you 3 into that gives you mass flow rate. Perfect. So this is 2400 kg per second should be there. Per second should also come at the back. Okay.
Yeah.
Though it is not there, but it is fine. Now this much mass is going in, so that much mass should come out. Fine. So what you did right now, you did it for 0.6. Now you have to did it for 0.25. No. Okay. So rho doesn't change. Resultant force.
0.25 times 5,
Uh-huh.
which is 1.25, and then I multiplied that by 100 to get
एक
the
minute.
1000 kg.
You got 0.25 and you multiplied by what? 100?
5.
No, 5. The velocity will change, no, Khushi, over there. A1 V1 equal to A2 V2. Equation of continuity. The velocity will change, beta. Here.
Oh.
Yeah.
I've not done that equation.
You I'll tell you this. In your textbook, current electricity, where there is drift velocity concept is being shown. They are showing that when the area is large, they are all moving with certain velocity, and it becomes lesser, the speed increases because now all of them have to pass through it. No, it's a very common thing. No, that we use funnel, right? We use a jet in our piping water, right? So what that jet does, it increases the speed because the area comes down. So what is the core learning here? The first learning is A1 V1 equal to A2 V2. This is called the equation of continuity. Okay. Equation of continuity. And what this teaches us is when the area decreases, the velocity will increase.
Okay.
Okay. When area decreases, the velocity will increase.
Yeah.
And when area will increase, the velocity will when area will increase, the velocity will come down. है ना? This is called equation of continuity. A1 V1 equal to A2 V2. है ना? तो ये तुम्हारा मीटर स्क्वायर है और ये तुम्हारा मीटर पर सेकंड है. ये भी तुम्हारा मीटर स्क्वायर है और ये तुम्हारा मीटर पर सेकंड.
Okay.
So first of all, get the अब अभी रुको पहले let us discuss first everything. So you will get the new velocity here, V2. Okay, you know the A2 thing. And A1, V1 and A1 are known to you. Number one. Now, he's asking you what is the resultant force exerted on the oil as it passes from X to Y. So what happens, Khushi? Very, very keen, important thing I'm telling you. See, when it is going from X to Y, you could see the walls getting tapered, right?
Yeah.
So whatever oil was coming here, got slowed down to this, right? That's where the walls are applying forces. Making sense?
Yeah.
And he's talking about that net force. Okay. Now, let me take you to Newton's second law. In Newton's second law, he has told you that the net force applied is dp by dt, which is change in linear momentum per second.
Right.
You can relate to that?
Yeah.
So if I have got a flowing water, okay, I have got the mass flow rate. Fine. That this much kg per second is flowing. Now, I have got the mass flow rate before and after. The mass flow rate is same. Okay. But the velocity is different. So mass flow rate times velocity will give you dp by the momentum. Okay.
Yeah.
So what you do, you get the mass flow rate here. You get the mass flow rate here. You get the velocity. So dm1 by dt into v1 minus dm2 by dt into v2. ये mass flow rate है और ये velocity. So mass flow rate into velocity is giving you linear momentum. Linear momentum 1, linear momentum 2. That is the change in linear momentum with respect to time. Okay, which will give you force.
Yeah.
Making sense?
Yeah.
dm1 by dt into v1 minus dm2 by dt into v2. Okay, this will give us force. Change in linear momentum with respect to time.
Yeah.
So beta, what you do, dm1 by dt is mass flow rate. That is something you already worked it out. Fine. That will not change. That is constant, but the V thing will change, which needs to be worked out using this equation. Okay.
Yeah.
Get the answer. Get the answer.
Okay.
Yeah.
Is it 12 meters per second, that V2?
Just a minute, Khushi. 0.6 से 2.25 हो गया वो, तो क्या किया तुमने, 5 इंटू 0.6 है ना, 0.25 नीचे लेके आ गई, 60/25, 5/5, हाँ, वेरी गुड, 12.
Okay.
So this becomes 12 meter per second. Perfect. ठीक है. So तेरा V2 आ गया. V2 came out to be 12. ठीक है. V1 came out to be 5. And dm1 by dt, dm2 by dt is the same thing only. This is not changing actually.
Yeah.
So you have got 12 minus 5 as 7 multiplied by dm by dt. What was dm by dt coming out?
2,400.
2500 or 400?
400. 400.
अच्छा हाँ, राइट राइट राइट, उसको मल्टीप्लाई कर दे 7 से.
Yeah, so it's 16,800.
Perfect. Now you could see the answer, right?
How am I this dumb? I don't get it.
अरे ऐसे मत बोला कर यार. हाँ? So you have to do, you have not, see, it's not your mistake. The point is you have not done this kind of practice in the school, no? Right?
No.
So how will you get that then? Right? That's why the classes are there. Now, what is my expectation from you is what we are doing, you will comprehend it properly, and then I will recheck your concepts. Then you should be able to do that. Okay.
Yeah.
And the second thing that I want to suggest you is, rather than mugging this all up, okay, try to feel what is happening. This will save a lot of time. This will increase a lot of number also in the subject.
Okay.
But what happens generally, students don't enjoy doing that contemplation. Okay. So, but if you have to do a deliberate practice initially, okay. So whatever I have told here, need not to mug it up. Just relate it to everything. What I did, when they asked me force, then I thought, how can I get force? Then I thought, oh, linear momentum was one of the things. Okay. Then I wrote linear momentum. It was dp by dt. Then I thought, how can I relate dp by dt here? Then I came to know v times dm by dt can be done. That is change in linear momentum with respect to time. So it's not a very easy intuitive problem if you don't know and did practice yet, right?
Yeah.
Go ahead.
Okay, for this one I put, wait, which question was this?
14.
For this one I put E.
मेरे को इसमें ऐसा लग रहा है तूने पी क्यू आर पूरा इकट्ठा ले लिया यार. एक्सेलरेशन ऑफ पी देखना था ना. You took no, nothing. I was just thinking in my mind.
Out loud?
Huh?
Out loud in your mind?
Yeah, the frequency is like that. Actually, I have not checked the solution. I could see something that you have made here, like P plus Q plus R together you have taken. Is this force F is, huh?
How do you know that?
You have sent me no WhatsApp.
Oh.
The lower part.
Mind or something. Scared.
You were scared. You know what? After 2 months, I'll be able to read your mind. Don't worry. I'm like that. After 2 months, I'll be knowing that what is going on. Okay. So I have that skill actually. Okay.
Okay.
So P is accelerated horizontally to the right by an external force. Okay. Q and R do not move relative. You know the concept of pseudo force. Okay. So you have put the answer as what? Answer as D.
E.
E for elephant. Let me check.
It's probably wrong. Everything is wrong.
They are giving the answer as B actually.
Of course they are. Easy.
So I will leave this question to you by giving you the solution here, है ना? So that you can revisit by yourself, because I believe that this is something that you will do, then it will make a lot more sense. Okay. What is the so I'm putting this on hold right now, because I think mm, you yourself will revisit, it will be better. Okay. 11th one.
Okay, so this one I wrote B.
B.
Yes.
Just a minute. B is the answer.
Oh, thank God. That's something, right? Homework. What
अरे,
question?
ऐसे ऐसे नहीं है. B is the right answer. Okay. Chalo. It's fine. Now your most unfavorite moments, right?
This one I got G, which I was surprised that it was a number that actually was one of the answers, but you know.
You were very surprised then, right?
Yeah.
G is the answer. G is the answer.
There's no way.
Oh my God. Can you send me the calculations on the group?
Yeah.
I just want to have a look out of my happiness, right?
This is rare. I'll send you 5 and 6.
G is the answer.
I'm very shocked.
Even I am shocked.
Wow. Okay. That's mean.
But after looking at solution, I won't be. I'll be very confident.
You might be.
Because I believe this is not a guesswork actually, okay?
It's not guesswork. I did proper working out for this.
Okay. That's why now I'm not shocked. Then it is fine. 74. एक मिनट रुक जा, क्या किया है? 240 into 1, that is fine. तूने फिर किया है 50 into 0.2 कहाँ पे है? 15 into 0.2, हाँ ठीक है 15 into 0.2 हो गया. 240 into 1, 740 into 1. Okay, change किया है मतलब okay. 1.
Yeah, I looked and I realized I made a mistake.
अच्छा, you were okay. 1.5 एक मिनट रुक जा. 1.5 हो गया into f cube. Wow, 660. Perfect यार, क्या बात है मतलब.
I know, right? Shock.
Now okay, that is fine. Good, very good. 660 is the answer. 2 of them you got correct. Chalo, tell me.
This one I got C.
Are you aware of the concept, Khushi?
I figured out that it had to be well, first I figured out
area under the curve.
Yeah.
No, what the area, what the area under the curve will give, like, tell me.
Is momentum, right?
Change in momentum, okay?
Yeah, change in momentum.
So initial speed was 30. Change in momentum is known to you, तो final speed भी पता लग जाएगी.
Yeah.
है ना? And you know the kinetic energy also, and you know the initial speed also, तो m पता लग जाएगा.
Yeah. So this one I got C. Is that correct?
I'll check it. I was just trying to get the feel that you have proceeded with all the required steps.
Yeah. I found M, and then I used that to find B because I already had U. So I did MB minus M2 over T.
Actually, I'm very much confident कि you will be doing something good here, but तुमने plus or minus कैसे किया है? I am confused with that actually. You know, Khushi, here the time is given in milliseconds.
Yeah, 0.004.
Okay, you use that.
Yeah.
नहीं तो then नहीं तो actually the wrong is because I don't know that what you did, right? This area is giving you change in linear momentum, which is P final minus P initial, okay?
Yeah.
Is equal to area under the curve. Making sense? Now P final, you have to find out the, see, the ball moves away in the opposite direction of the initial motion. Okay. So if initial motion is like this, then the opposite motion is like this. So these things will get added up here. These things will get added up. ये 30 से जा रहा है, ये 20 से जा रहा है. So if you are taking this as positive, it will be minus mv minus 30m equal to area. That's please redo at that part and give me the answer.
Is it A? 20?
Yep. So that's why I was worried. I was damn sure that you knew the concept, but I was also damn sure that you have skipped this part.
Yeah.
Okay. So these are the important things, no?
Yeah.
That's where they get you wrong.
Yes.
Okay. Coming to the last question.
Interesting question in that I had no idea. And I picked F because it looked right.
You picked F.
I didn't know. I didn't know how to do this.
Acha, let me first see what the question is all about. First of all, will they attract or repel? Tell me that.
They attract.
They will attract. So this will move like this and this will move like this.
Yeah.
And after collision, they will become together. So this is called a inelastic collision. Okay, they become together, but the linear momentum initial was 0. Initially, were they at rest? Yes, they were at rest. So finally, also they will be at rest.
Yeah.
So what you need to check, Khushi, is the mass of x. This is 2m and this is m. Okay. So in any case, the velocities that will suit will be such that the net linear momentum is 0. That should be the velocities actually. For example, x wale ki velocity you have v. So for y it will be v by 2. So for x ke liye it is velocity is v. So for y it will be 2v. So that the net linear momentum becomes 0. Is it making sense? Yeah. So which row of the table gives the magnitude direction of velocity of the two magnets after collision? So what will happen? After collision, it will be at rest, no? Because initially they were at rest. And if so, linear momentum is conserved, right? So finally also the linear momentum should be conserved, no?
Yeah, that's fair.
Initially linear momentum is 0. Once they stick together, all the forces that are acting are internal forces, no? There is no external forces. So by conserving the linear momentum, the final velocity should also be 0.
Yeah. That makes sense.
That was my favorite 0 answer.
Of course.
Isn't it?
Yeah.
So now some of the questions are left in Enga 2. I have given till here only. Okay. This is the answer. So I am sending this homework. You can revisit this homework.
Yeah.
And get a note of what better you can do. And for the 14th question, what I do, without putting it pending, I will put the solution over here, small solution, what he has given, so that everything is there at one place. I think everything is discussed, and this will help you in the revision part. Because you will be maintaining this either digitally or in your proper workbook, right? So that will be required a month before the exams, as we'll be redoing this stuff.
Okay.
So now mechanics is something, especially when it comes to physics, probably in maths, you might have achieved a level but in physics we need to work so that we can reach to the level what questions are coming in. You know?
Yeah.
Fine, I'm sending it.
Okay.
Then we will start with the. Should I open your book in current electricity, or you will give me direct questions and we can start from the questions that you wish to discuss on potential divider? Is it potentiometer that you are talking about? Potential divider?
Yeah, you're talking about potential meters.
The instrument that is used to measure the EMF of the cell, right?
Yeah.
So how detailed it is given over here? Which page should I come to in this book?
I think it's chapter 11
Mm-hmm.
or 12 because I think you have the older book.
I have the
You might call.
practical, potentiometer circuits. Yeah, page 172.
Yeah.
So have they taught you in school?
Yes, they have.
Have they shown you the potentiometer over there?
No, we haven't actually done the thing.
You haven't done the practical.
No, not yet.
Mhm. You do they promote practicals, like they are keen on those things, or they try to avoid?
No, we didn't put it new. I just something we done this one. We did the potential divider one, but we haven't done this.
Okay, no worries. Just let me have a look that how much is of it is done practical circuit. Then I will give you my explanation to that. Are you comfortable with these things, Khushi? Potential divider.
I think so.
Okay, let me bring a problem to you and then we will discuss about it. Okay. So whatever here is given, it can go very easily by nodal. You can put 0 0, you can do that, and you can do the drop and you can get the drop across any register, right? We have done such problems also in a good manner, right?
Mhm.
Probably you might have noted them down, the lecture that we did on current electricity initially.
Yeah, I do.
Okay. Then comes the potentiometer stuff. Okay. So have they taught you the theoretical part of this potentiometer circuit? What it is and what it is going on here?
Yeah, they have.
What is your understanding?
So it's usually a guidance cell connected to a long wire.
Mm-hmm.
You place another wire across and connect to different parts of that long wire, and you have a little smaller cell.
Okay.
That connects to that wire.
Mm-hmm.
And you can find a balance point where the voltmeter or the galvanometer that we use is reading 0 because
Mhm.
the EMF cell is equal to the EMF of that piece of wire that you're connected with
Mhm.
at the volt potential difference. So yeah, that's the basic theory. We didn't go into that much depth because I'm not sure it's that big of a thing in our spec.
I'll explain everything. Okay, don't worry. Okay, I'm starting. I will tell you the whole story, what is going on, why everything is there, and there is no need to mug up anything over there. Okay.
Okay.
So, first of all, when we talk about potential divider, okay, let me give you an example of that, and then I will move to potentiometer. And like half an hour is good enough for me to summarize everything, and I will be practicing problems in our Sunday class for that. Okay.
Okay.
So, first of all, give me a quick answer to this. Like, for example, if I have got like 3 registers, they are connected by a, let's say, 10-volt battery.
Yeah.
And this register is 5 ohm, this is 3 ohm, and this is 2 ohm. Can you tell me the potential difference across this? If I take potential difference reading, I put a voltmeter. What will be the voltmeter one reading here? and the voltmeter 2 reading here?
V1 will be 3 volts and V2 will be 2 volts.
गलत बात है, सोच के नहीं बोला आपने. खुशी, खुशी, 3 ohm and 2 ohm, both across them there is a net drop of 10 volts. Okay.
Okay.
Do the nodal method. No, I explained you that day. 0, 0, 0. Okay. And this is 10, this is 10, and this is 10. Fine.
Yeah.
So in the 5 ohm, the current flowing will be 2 ampere.
Yeah.
10 minus 0 by 5. Okay. Even in this one, this V1 and V2 is something I have made to get the reading of the voltage. Otherwise, the current flowing will be 2 ampere only, right?
Yeah.
Then I told you that the drop that comes in the direction of current is I into R.
Yeah.
You remember?
Yeah.
Tell me what will be the potential here.
So across the first one, it's 2A times 3 ohms, so 5.
2 into 2 times 3 is 6, no? So here it will be.
And I'm not clear.
You're not hearing me? So here the potential will be 4 volts, no?
Yeah.
So 10 volt is here, 4 volt is here, and 0 volt is here, right? And यहाँ पे 10 volt से 0 volt हो गया, right?
Yeah.
Very true. I understand what you're saying. Ab, so you could see very well, Khushi, that this 10 volt is getting divided in the ratio of resistances. Like here the delta V is 6 volts, and here the delta V is like 4 volts, right? That is how it is divided, no? See, 3:2. When you divide 10 in the ratio of 3:2, it is 10 into 3 by 5, which is giving you 6 volts, no? And 10 into 2 by 5 is giving you 4 volts over there. 4 volts over there, 6 volts over here, right?
Yeah.
That is how 10 volt is getting divided. Done?
Yeah.
So this is where the potential divider is playing a role, right? Potential is getting divided based on how much current is flowing and what is the resistance, okay?
Yeah.
One more thing I wanted to ask you before moving further. This is also I told you that day. I don't know whether you remember right now or not, but you will be doing it right now. Like 10 ohm current is flowing in the mainstream, okay? And now I have got 3 resistances, 3 ohm, 2 ohm, and 5 ohm. What are the currents I1, I2, and I3 flowing in them?
I think he's like the most current goes to the smallest.
Exactly. Do the calculus, do the maths and send it to me. I told you how to divide it in the ratio. I remember.
Yeah.
Sorry? You're finding notes.
Yeah.
Why are you finding the notes here? I told you, no, inverse ratio में बांटना है. Do use the mathematics knowledge, na? Huh?
Is it then 5?
नहीं, पहले सुनो. पहले थोड़ा brainstorming करो. Do a little bit of brainstorming. Don't get bogged down. I1 is to I2 is to I3 is have confidence. You will able to recall the concept, okay? Then you will recall the method. Don't jump to notes.
Okay.
I1 is to I2 is to I3 is 1 by 3 is to 1 by 2 is to 1 by 5. Making sense?
Yeah.
Now take the LCM, Khushi. Okay? You will come to know I1 is to I2 is to I3. Based on that, I1 nikal lo. Okay, karo.
So it's 15 to 10 to 6.
एक मिनट यहाँ पे अपना LCM will come out to be 30, so it will be 10 is to 15 is to 6. Yes.
6. Yeah.
So if somebody is asking you I1, then I1 will be 10 into 10 upon 10 plus 15 plus 6.
Yeah.
Making sense?
Yeah.
This is what I1 is.
Okay, yeah.
Similarly, you can get I2 and you can get I3 also. So these are the two things I just wanted to touch upon before proceeding further on the story of potentiometer. Fine. Yes. Now it will be a very, very interesting story. And I will be, yeah, it's a very interesting story actually. I enjoy teaching potentiometer because I don't allow my students to mug that up, right? There is a wire and that all. Everything should come in, that why it is there. Okay. Then it becomes a really good story. So yeah, when we go to laboratory, there are two instruments, Khushi. One is called voltmeter. Okay. And one is called potentiometer. Both of them are measuring delta V. Very surprising, yeah, right? Yeah. You might have heard of voltmeter also. Yeah. And now you are getting potentiometer. So yes, if I was having such a handy instrument, which is called voltmeter, okay, then why should I get a potentiometer to measure the voltage? Why not only voltmeter can be used? This potentiometer can reduce the current to 0. You yourself know that this is not the right answer. That's true. Right. While saying it, you right. So let me tell you the story. देखो इसको समझो अच्छे से समझो. One day I was going on the road and I found a battery lying over there. Okay. And there was no marking on that battery. Everything got erased out. Okay. Now a curiosity came to my mind that let me find out the EMF of the battery. Okay. Every battery has got a certain EMF and it has got a certain resistance. Okay. And that resistance is called the internal resistance. Fine. Yeah. Now listen to me. So I picked up this battery and I decided to find out the EMF. You know what? EMF is voltage difference across a battery when no current is flowing through it. Because battery is something like this. This is the basic battery actually, which has got some EMF here and it has got some small r here. If current is going through it, then the voltage that you can read through will be EMF minus IR. Yeah. Is it make sense to you? Yeah. Yeah. So what I took, what I did, I took this battery. Okay. I took this battery and that time I was not aware about potentiometer. So I took this battery and took a voltmeter and I attached this battery over there. Okay. Now what happened? That voltmeter gave some reading, but that reading was EMF minus IR, not EMF. Yeah. Making sense? And the irony is I didn't knew either this or this. So the point is even by getting a reading, I am unknown about both the variables. Yeah. That's why I bring in potentiometer. Yeah. Which gives me absolutely accurate reading because it is doing the work when there is no current flow. So this part is getting reduced and I can directly read the EMF. Yeah. So potentiometer is a powerful instrument which gives very accurate reading. Then another question arises, why we use voltmeter then? Voltmeter is very handy. Potentiometer is a bulky setup. So if there is a small circuit and you try to get potentiometer connected to that where voltmeter is working fine enough, there's no point getting potentiometer. So because of the handy nature of the voltmeter, it is usually preferred. But if you want a very, very accurate measurement, especially of the EMF, then you can't use a voltmeter. Very accurate measurement is being done by potentiometer. And the answer lies in the fact that you only said, because potentiometer is delivering us the reading when there is no net current flow in that branch. That's why it is able to separate EMF from internal resistance, and it can deliver you the reading of EMF.
Yeah.
Making sense?
Yeah.
So that is the use of potentiometer. Now that is the why the potentiometer thing came in existence. Okay.
Okay.
Now this part of the story was the introduction. Okay, that why potentiometer is powerful. The use of, we have two uses of potentiometer. One get the EMF, one get the internal resistance of the battery that we found somewhere lying, which has got no marking on it. Now the next question arises is, how do we do that? How to do that? So it's a very simple overview. In a potentiometer, there are two kinds of circuits. One is called a primary circuit, one is called a secondary circuit. And the most beautiful thing is, both the circuits are enjoying their own lives. Nobody is interfering, especially at the null point.
Okay.
Null point is what? When you get a zero reading in the galvanometer.
Okay.
So
Why won't they interfere?
why won't they interfere?
Yeah, how so?
I'll tell you. I'm coming to that actually. Its interference is not at all desirable. Actually, it will mess up everything. You know.
Yeah.
So, but why will it happen? I'll tell you. So, primary circuit is something, Khushi, where I know everything. Okay, this is something that is in my hands. And secondary circuit is made up of the unknown thing that I got from the floor, right? That unknown battery which has got everything erased, right? That is something I attached in the secondary circuit. I'm through the help of the primary circuit, I'm trying to get the EMF of the unknown cell. Okay.
Yeah.
So now what is there in the primary circuit is a battery. There is some resistance. There is a very, very long wire, which is called a potentiometer wire.
Yeah.
Let's say this resistance is R naught, this battery is V, and this very, very long wire is having a resistance R. Resistance is R.
Yeah.
And length is L. Okay. So I can also remove this. I have a choice of removing this, but I know this is my primary circuit, Khushi. So in this primary circuit, my total current flow will be, the current flow will be V upon R plus R. This is the current that is flowing in this primary circuit. Okay.
What is that page?
वो मैंने आर नॉट में ही मान लिया, मतलब अभी के लिए मैं तुम्हें डायरेक्ट वो वी दिया है उसका ईएमएफ. आई एम नॉट कंसर्न्ड अबाउट दैट एक्चुअली, फ्रैंकली स्पीकिंग. आई एम मोर कंसर्न्ड अबाउट द बैटरी दैट आई एम ट्राइंग टू फाइंड आउट द वो. ओके, अगर इंटरनल रेजिस्टेंस दिया होगा मान लो स्मॉल आर, तो वो भी जोड़ देना नीचे, स्मॉल आर लग देना प्लस आर. ठीक है. सो बी ओके, so don't worry about that. Fine. Now we came in and we brought our battery. We joined it like this. And we've got a galvanometer. Galvanometer is a device which has got a sensitive needle, which will be at zero when no current flows through it. Okay.
Yeah.
And there's a key attached, and this key can be driven over on the wire. You can drive that key over on the wire. Okay.
Yeah.
Now there's a specific point where these two are not interfering, the red and black. That specific point is called null point. Otherwise they interfere. But at this specific point where you are getting null point, what is that null point? When there is no current. No current. So let's say this occurs at a distance x from this end.
Yeah.
At this point, you take the reading, and at this point there is no interference because I is zero, no?
Yeah.
That means nothing is coming in from here. Everything is going, this eye is totally passing through. It's not getting diverted. That's why we are saying they are not interfering. Otherwise, if this would have been towards left or right, they would have interfered. right? This would have shown reading. But my point of interest is the point where there is no interference at all.
Okay.
Making sense?
Yeah.
One more important thing. The connection of this battery should be done very carefully, keeping the higher potential connected to this point, similar to this battery.
Yeah.
For this battery, the higher potential is connected to this point. For this battery, the higher potential is connected to this point. Okay.
Okay.
Is it fine? Why? Why? Because when you come to this point and as you go towards right, there is a drop in potential. Okay.
Yeah.
So here also a drop should happen. No, the drop will only happen when the higher and the lower will be like this. See, when you are going in the above circuit from here to here, you know that there's a drop, right?
Yeah.
You know there is no current in this branch. That means the potential here and the potential here is same, right?
Yeah.
So, and the potential here and the potential here is also same. Fine.
Yeah.
Here and here is also same. Here and here is same. So there is a drop here. So there should be drop there. I am saying here and here the potential is same. Let's say V0 and V0. Fine.
But how?
I'm giving this any name of the potential. I'm not saying it is V or something else. I'm saying it is something V0 or something X. I'm not giving it a number based on the calculations. I'm telling you, I'm just giving you the logic that why the higher potential of the battery should be like this. Because at the top there is a drop in potential. So you are expecting a drop here also, and drop will only happen when the higher bar is here and the lower bar is here.
Okay. Yeah.
Is it making sense?
Yeah. Yeah.
Then only agar if you invert this battery, no, you will never ever get the null point.
Yeah.
Because what will happen in the lower circuit, there will be a rise. In the upper circuit, there is a drop. So in no case you can get the potential same at these points, no? So how will the current will become zero in the galvanometer? In order to make the current zero in the galvanometer, the potential here and here should be same, no?
Yeah.
Starting from the same points, you are getting the same drops above and below. Okay. So below I am getting a drop because of this battery. I know. And I know the EMF of this battery is EMF. There is no current flowing. So I know that the drop coming below is EMF. I know that the drop coming above is I into resistance of this part. Making sense?
Yeah.
So EMF comes out to be I into resistance of that part, and resistance of that part will be R into X by L.
Yeah.
Isn't it?
Yeah. Yeah.
That is the thing. Now you have got the EMF because you know X, you know I, you know capital R, you know L, you will get the EMF of the battery.
Yeah.
That's all. That's all. और अभी इतना सारा पता नहीं कुछ याद नहीं करना ना, मतलब इतना लॉजिकल है, ठीक है, कि हम क्या कर रहे हैं, whatever we are doing, no, every step has a logic to it. You can't get battery inverted, Khushi. You won't get a reading. See, so what is the core idea? The idea was there was a circuit. Okay, imagine like this. There was a primary circuit, and in that there was a very long wire. On that wire, there is high potential and there is a drop of potential towards the lower. Fine.
Yeah.
So what they thought, these guys thought that if we bring a battery which is giving you a drop similar to the drop on the wire on a certain piece of length, the drop along the wire and the drop along the battery becomes same, that will cause zero deflection in the galvanometer. That is the idea that they thought of. And these guys can change the X and can make the length change, which can get adjusted to n number of batteries you can bring in. It's not only one potentiometer can measure only one kind of EMF, right? It can measure very different kind of EMFs by changing the X values.
Yeah.
What a great thing we came out, right, with, which has got so many variations possible.
Yeah.
It's not Huh?
made this? Like the potentiometer.
Probably after 5-10 years, we'll be hearing that Khushi also made something of that sort, right? Huh?
Okay.
I really want you. You should go for PhD, Khushi.
Me?
Yeah. After engineering, go for research. Okay. I tried it for a while. Okay. And then I left it. Yeah.
Oh.
Hmm. Because I realized that I'm not the person, right? I had a publication, by the way, right?
Oh.
Yeah. So, but that was the last thing that I could bear. And I thought now this is good enough. I should not get into more into details, right? So this is good enough, right? So it isn't a really nothing to mug up, right? They have a very clear mindset. Like over the wire, there's a drop. I want a battery who is getting similar drop, so we can match the length and we can get the current zero in the galvanometer. That's all.
Yeah.
That's all. Now, once you find the EMF of the battery, the next step, they are expecting you to get the internal resistance of the battery.
Yeah.
Isn't it?
Yeah.
So for that, what they will do, they will do a little more mathematics and they will increase the secondary circuit. They will increase the secondary circuit in a way that there is a current flow in the secondary circuit, there is a current flow in the primary circuit. Still, they are independent. They are not exchanging currents. Okay, but they are making an extension of the secondary circuit so that there is an internal current flow over there. And again, they are doing the same stuff. Whatever drop is taking place on the balance length is the drop taking place over here. But right now there is a current flow. You know the EMF, so you get to know the small r.
Yeah.
Is it fine?
Yeah. Yeah.
Though I have not drawn that circuit here, but is it there in your book? I think now when you will read it, it will make more sense to you.
Yeah. Yeah. It will.
Isn't it?
Yeah.
So what I am planning to do is I'm planning to do some good questions with you on my Sunday class.
That's good.
And Sunday class, you prefer to have me earlier, right? In the evening time.
Yeah.
But I prefer this time only actually because what happens like 6:30 to 10 p.m. I have commitments with Indian times 6:30 to 10 p.m. And
Yeah.
by 10:30 I will be reaching home
Yeah.
India time. So otherwise in the morning I am.
Okay.
This is okay, na?
Fine. But yeah.
Yeah, 11:30 p.m. we will keep a fixed time for you. 11:30 to 1 India time. I have kept a fixed slot for you.
Okay.
Friday, Sunday. Okay. Now, sorry.
How many students do you teach?
At the moment I have like 25.
Oh wow! In 1 week.
Yeah, in 1 week. I mean, my hours like in a day goes like 11, 12 hours sometimes.
Oh wow!
Yeah. So I enjoy teaching actually.
Oh good.
Mm.
Okay.
So okay. Now, have you attempted any of the questions, Kushi, in this part?
In the book?
Yeah.
Yeah, I've done all of these actually.
And what is your comfort level, by the way? Is it like you managed to did them or they are intuitive?
I mean, it really depends. But I can do the circuit questions with equations.
Okay.
But some of the theory or some of the more complicated questions, I have to like struggle through. I keep hearing that phrase in physics.
Acha.
Struggle perfect.
Ha, 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 ha. Okay, now fine. I got your point right. So, what I will do, I will send the recording also. this whatever we have done the recording, I think you will need to just comprehend this potentiometer concept, right?
Yeah.
And my next class will be what I will do. You finish the Anga thing, whatever I have given as a homework. My next homework will be on current electricity. Okay, next week we'll be dedicating that week to current electricity. Okay,
Okay. Yeah.
fine, fine. So it's good enough. I think we can proceed with problems in our next class then. Okay,
Yeah.
take care. Bye. Good night.
Okay.